Hi there, everyone. Welcome back. Now, I'm here at my MacBook Pro. We're going to take things a little step further than what we did before. So we just spoke about hashing. We spoke about how it works, the algorithms that take place. Three common algorithms: MD5, SHA, SHA-256. There's a boatload others. In this example, I've got my MacBook Pro here. I've gone away and I've downloaded Google Chrome. Now, there's different ways of obviously, we're going to take two examples in this scenario. So I want to showcase the application. So I've just gone to the Google website. I've downloaded the application on my MacBook. And then I'm going to spit out the hashes of those in three different forms. We've got MD5. So I'm just going to put it here. So we've got Google application. And then we've got our MD5 SHA, MD5 SHA-1, and SHA-256. Now, SHA-256, just keep in mind that it says 256-bit value. SHA-1 has 160-bit value. And then MD5 is your 128-bit value. So in another video, we can probably talk more around the security ways around these two things, these three features. But in this particular example, let's just maybe, I want to keep this quite simple. It's more of a demo than more of a discussion around MD5 and SHA. Just know that each of these values have their own sort of security strength associated to them. So you'll see that MD5 is a little bit shorter than the SHA-256. SHA-256 is more widely used in a lot of the environments today. It's obviously more secure. Obviously, the more bits, the more secure the hash is going to be. So with that in mind, let's proceed now with spitting out these hash values. So there's a couple of ways to do this. One is we can, different forms. Again, if we're running Windows has cert-util. We can do that with PowerShell, different sort of commands to do the same thing. Linux also has its own commands and ways of doing that. Just in terms of simplicity and keeping things as easy as possible, I've got a Mac in front of me, so I'm just going to be using that. MD5 is the command. So MD5 is just saying, yes, let's just use MD5 as our hashing algorithm. And then I'm just going to specify the actual file itself, which is our Google Chrome file. And then it spits out its MD5 value. So nice and easy. I'm just going to go away and do the rest for the other two. So SHA sum is the command to get our SHA value for Google Chrome. Now, should we need to go on the Google Chrome website, we can then validate the SHA sum or the MD5 SHA or whatever hashing algorithm that they've specified online. We can run the same encryption algorithm or the same hashing algorithm and then spit out the same value. So I didn't even notice if they did have a hashing algorithm online, but that's one way of confirming that. Now, multiple vendors may have this online. You can just go to the website, they'll have the hash value and say, here's our MD5 hash. And that's great. We can download that, run the same MD5 command that we just did, and then we can then validate that the hash that we've received to the one that's online is obviously accurate and has its truest form of that application state. So you'll see in a moment as well, in another example that I do want to show you is the text file side of things. We'll start manipulating the text file and then you can start to see the difference of hashing algorithms. So let's go back now and generate our SHA-256 value. So SHA sum, very similar command. Tag A just says, let's just have this option. So the option in this case is 256 value. And then we're going to put that up against our Google Chrome application. So I'm just going to copy that and paste that in here. So you can see that there's three forms now. SHA-256, obviously the longest line, 256-bit values there, and then you've got our MD5 and SHA-1. So both in different variants and different forms of algorithms that were running against the original state of that application. So I'm now going to take this a step further and let's just do a file. So this is now a file in terms of, let's say it's a document, PDF, could be a Excel file, whatever file this can be. In most cases, many years ago, you can do this in one form. Now there's obviously a layered approach to security. You may have a very secure way of sending files to customers. You may have an encrypted file, send them the encrypted password in a form of out of bounds access. You may send them the hash file. You may send them the ziploc, if you've zipped up the file. If you're using a secure workforce environment, you may have your own, virtual desktop infrastructure that you open up to your customers. There's many different ways of secure transferring files There's a lot of great open source tools to do that. This is not an example. We're going to run through that at the moment, but should we need to send some files, we can hash the file out. We can send that to the customer or send it to someone, show them the original state of the data and say, look, this is the hash. When you receive the hash, run it through the SHA-256, SHA-256 algorithm. If your value is this, then fantastic. Nothing has been altered, nothing has been tampered with. The state of the data is accurate and it is original. So this is the example that I want to show this with you. So let's just create a file. Let's create some text and then we'll spit out the MD5, we'll spit out the SHA-1, we'll spit out the SHA-256. And then what we'll do is we'll do some alternate text. So we'll do alternate text 1, alternate text 2. If you're familiar with, steganography, we can probably do some more videos around that a little bit later. But if you've used Stego in the past to, conceal or, send data out, steganography is an awesome way to, obviously to conceal data and to do that sort of stuff. There's two great tools that are still widely used today. One is called OpenPath and the other one is called Mental Freeze, and Snow is the other one. Snow uses pretty much white lines. So use the white lines method. Just it's a blank document like this. You can conceal things in white lines so it doesn't look as text. It could be like, credit card, maybe information, could be things that you want to conceal to send out of the organization. OpenPath, you can then use things like MP4, like file, music file attachments like an MP4, maybe like a picture, and then it rearranges the data out. So, as the receiving end, you'll have to use the same form to decrypt the data, and then you'll get the original state of that data with either the concealed information or, whatever that you're trying to put into that file. So what I want to take in this example would be the Snow-like mentality. Since we're using a file to do some testing, I'm going to use the white lines or just add alternate text to the actual document, and then we'll see the differences between the original file, the alternate data. Even just adding one space in the text can alter the hash. So let's do that first. Let's go through and we'll create the document. In this case, let's just go, hello friends. Today we are talking about hashing. Isn't this so much fun? And I'll just copy this. Let's go back into our terminal. Let's create our file. So I'm going to echo this out into hello friends. Today we are talking about hashing. Isn't this so much fun? And then I will close that out. And then let's just send that out to hashing file.txt. And our txt file is here now. And I'm just going to cut this out just to make sure that the text. So this is now our original text. So here's our file. Now this obviously, if you've got a document, with sensitive data, it's not going to be a couple, it's not going to be a line of words. It's going to be, multiple pages of maybe sensitive information. Could be a maturity assessment, could be a, a gap analysis, could be a penetration testing report, could be, whatever, nature of assessment someone is doing, or whatever the nature of the document is. If it's an Excel document, it could be some sort of, payroll information. The same sort of concept kind of applies. So we've got our data here. So that's the original state of the data. Now let's run it through the MD5, SHA-1 and SHA-256 hashes. And then let's get those out so we can start to see what the original content of the file looks like. So MD5 hashing file. Here's our MD5 string. I'm just going to take a moment to spit these out. Hashing file. So there's our SHA-1 value. And then we'll do the same SHA-sum, tag A for the option, and it's 256 bits we're going to use, and the hashing file. So there's our 256-bit version. So fantastic. So there's the original, I guess if you call it the original form of each of those hashing algorithms across that file that we've created, and that's in the original state. So right now, the current state is that hello friends, comma, today we are talking about hashing in capitals, full stop. Isn't this so much fun, full stop. So that's pretty much the original state of this file. So now let's go and take it a step further from here, and then let's start altering out some data so we can start to see how that kind of looks like. So I'm just going to space it out here just to get a little bit of real estate. Feel free to check out OpenPath, check out Snow. They're really cool. You can use Snow at the command line and then open up a terminal, things like that. OpenPath is an application, you can download it, and then you can start playing around with it and start to see how that works. Next step from here is let's create some alternate text. And in this particular example, I'm going to use the SHA-256 hash algorithm as the original text. So I'm just going to paste OG hash is here. So that's the OG hash. And then I'll do the same for these ones, just so we can keep the consistency and information to ourselves. G. Alrighty, cool. So in all these examples, I'm going to be using the SHA-256 hash just for, for simplicity. So let's do alternate text 1. So let's go back to our file. I'm going to nano this out so we can edit it. And I'm going to do one thing that's just really, really simple. I'm just going to add a line of space, right? I'm going to save this, and then I will run the file again. I need to specify the hash, sorry, the actual file name. So let's cut out the hash file. All right, so you can start to see that there's obviously a space there now. And then with the SHA-SUM, I'm going to spit out the new or the alternate text file. So you can start to see, even with a line of spacing, that the original version is obviously been altered. It's now starting with CEC opposed to 1E2. So even just a line of code or a line of space has altered the actual state of the hash file. So let's go back. I'll nano that out again. And then instead of a line, I'm just going to get rid of the line, and then I'm just going to add some more text, right? So altered text has been added. Thanks for that. Okay, save that. So file is still there. I'm going to now just do the same thing again. SHA-SUM 256, and then hash file, and then alternate text 2. So you can see again it's changed. So now that we've added the extra bit of text, it's again changed from that line item that we've placed in the first step to an AA3 thing. So it's obviously changed again, right? So that's great. So now this file is no longer in its current state. So obviously, right? So there's been a bunch of text that's been added. Now this is true if there's anything that's been tampered with the application, if maybe a line of code has been introduced to do something else, it's no longer its original form. So let's go back, and I'm going to remove all the changes. And I've got a question for you. If I've removed all the changes, does the data then go back to its current state? So will the hash now present itself as its current and original format that we've had, which is this 1E2 hash value? So let's have a look and let's see if this actually works. So just open up our hash file. I'll go away and I will remove all the additional text. Keep that as is. So that should be as current, full stop and full stop. And I'll make sure there's no lining up here. Cool. And let's save this out. Just one more look at it. So, whoops. Okay. So it looks about right. So let's run our SHA-SUM 256 again with our hash file. And it looks like it's changed, but I do think there's something wrong because it shouldn't. It should actually go back into the correct state. So I think because we've got our space there, and I'll get rid of any spacing here, add that back. Just save that out. And that has now gone back to its original state. Now, you may argue and say, Andrew, well, that's not the original state. It's been already tampered with and altered. Well, yes, it has been altered and tampered with, but in terms of the actual original state of the data, it actually has gone back to the original state, right? Which is our line of code, which our line of text, I should say, not code, which is, hello friends, today we're talking about hashing. Isn't this so much fun? And it is back in the form of the correct uppercase, full stops, etc. So as you can see, we've gone through the examples of the application state, how to generate hashing for the application. We've gone through the actual text file, nice and easy. So you can start to gauge and understand that once we make any changes to the application, either by full stop or adding extra spacing, or obviously extra words or text, it obviously impacts the integrity of that file, meaning that it is no longer in its original form. So I do hope you've found this video useful and handy. Please, obviously let me know if there's any comments, and I'll see you guys in the next video. Thank you for watching.